Good evening everyone. Welcome to our channel Sapiens Educations as well as Institute. So today I am going to discuss about the NCERT solution for class 12 physics. And our chapter name will be moving charges and magnetism. So from here we are producing a part 1 video so that uh, it will cover almost 7 questions. So let's discuss one by one. So let's go for first question. First of all, before solving any physics problem, you need to go through all the questions, right? Go through the questions and read it properly. A circular coil of a wire consists of how many turns? 100 turns. Each of a radius of 8 centimeter carries a current of 0.4 ampere. What is the magnitude of the magnetic field at the center of the coil? So before that, we need to understand that the scenario. So there is a circular coil like this, and this coil contains so many turns of the wire, and each wire will have it's like this. If you see it vertically, so this is like this, right? So this is a circular coil, right? And we need to find the magnitude of the magnetic field at the center of the coil. So let us suppose this is a center O. So we need to find the center. So what they have provided you? They have provided you n is equal to 1, that is equal n is equal to 100, that is number of turns. So we can say that it is the number of turns of the coil, number of turns of the coil. And after that we have r, that is radius of the coil. So this is equal to 8 centimeter. So this we can say that 0.08 meter is the radius of the coil. And if you talk about the current carrying inside this coil, is this is equal to 0.4 ampere, right? We need to find a magnitude of the magnetic field, that is B. So how you will find magnitude of the magnetic field? So let's solve it, right? What formula we need to use? So B is equal to mu naught by 4 pi into 2 pi n I by R. So this is the formula if you want to find the magnetic field at the center of the coil. So we know that the value of mu naught by 4 pi is equal to 10 to the power minus 7. So we can put here 10 power minus 7 into 2 into pi into number of turns is 100 into current is I is 0.4 divided by R is equal to 0.08. Now when you try to solve it, so you will get approximately 3.14 into 10 to the power minus 4 Tesla. So I hope you have understood. So this is our solution for this question. I hope you have understood. If you have any doubt, you can comment in the comment section below. Now let's go for next question, and next question itself is question number 4.2. So first of all, read the question. There is a long straight wire carries a current of 35 ampere. What is the magnitude of the magnetic field B add up 20 centimeter from the wire? So there is, we don't know about this wire, so let's go for this. So there is a infinite long wire. And we need to understand that we need to know that the magnetic field B strength of the magnetic field, which is at a distance of 20 centimeter from this wire, right? How to find this? So basically, if you have gone through the derivation part, so you have understood that how to find the magnetic field distance at a distance of the r. So if you use this formula, B is equal to mu naught by 4 pi. B is equal to mu naught by 4 pi into 2I by r into 2 into current by r, where r is the distance. Now we know that the value of a mu naught by 4 pi, that is equal to 10 to the power minus 7 into 2 into the current. Amount of current is how much? It's a 35 divided by r. So r basically the distance from the wire, that is equal to 20 centimeter. So try to always convert it in standard unit. So this will be 0.2 meter. So put the value, so 0.2 meter. So finally you will get 35 into 10 to the power minus 7. 35 into 10 power, or a no, it's a 0.2, no? So it's 0.2 So it will be 35 into 10 power minus 6 Tesla, or we can say 3.5 into 10 to the power minus 5 Tesla, which is the standard one. So you can write any one of them. I hope you have understood this question. Now let's go for next question, that is question number 4.3. So in question number 4.3, a long straight wire in a horizontal plane carries a current of 50 ampere, right? Again, you try to read those question. There is a long straight wire in a horizontal plane. So first of all, we try to make a horizontal plane. So let's do make a horizontal plane so that you can easily understand this one, right? So this is the horizontal plane, carries a current of high 50 ampere from north to south. So in this, try to give the direction. So let's put the direction. So let us suppose this side there is a north side. So this is a south side. This is our east side and this is our west side, right? And now in this section we can say that the current, a straight wire in a horizontal plane, carries a 50 ampere in north to south. So this is the current carrying wire. So this is our current carrying wire, and it is current carrying wire, right? And it is carrying a current of 50 ampere, right? In north to south direction. Give the magnitude and direction of the B at a point 2.5 in the east. So let us suppose there is a point, it's toward east, which is B, and I want to know the magnetic field strength at this point. You know that the current is carrying like this, so the magnetic field, how this magnetic field will be created. So let us suppose this type of direction of magnetic field will be created, right? So no, its direction should be opposite when you use right hand thumb rule. So its direction should be opposite. So let's put the direction. So let's try to create a circle, and in this direction it will go inside. So in west direction it will go down, in east side it will go upside. So the direction of the magnetic field will be vertically upward, right? At B, right? Now the magnitude of the magnetic field. Now we need to find the magnetic magnitude of the magnetic field. So we know that the formula which can be used here is equal to mu naught by 4 pi into 2IR, again 2IR, right? 2I into divided by R, where R is the distance, right? So what they have provided you in data, so let us suppose they have provided you current I is equal to 50 ampere, right? And R is equal to 2.5 from the east. So just put the value. So this is again mu naught by 4 pi will be equal to 10 to the power 7 into 2 into current. Current is 50 divided by 2.5 meter. So again, if you calculate it, so how much you will get? Let us suppose B, when you calculate it, so approximately not approximately, perfectly you will get 4 into 10 to the power minus 6 Tesla. So by using this, you can easily understood this, how to easily understood. I hope you have easily understood this one. So let's make a box of it. Okay, so I hope you have understood question number 4.3. Now let's go for a question number 4.4, and it's let's read this question. A horizontal overhead power line carries a current of 90 ampere in the east to west direction. What is the magnitude and direction of the magnetic field due to which the current 1.5 meter below the line? So you know, first of all, try to understand there is a overhead wire power lines. So let us suppose there is a overhead power lines like this. So there is a overhead power line. You have seen that there is a overhead power lines, right? Like this. So there is a overhead power lines. Okay. So there is an overhead power lines, and power lines carries a current of 90 ampere from east to west. So let us suppose this is east, this is west, and in this direction it is north and it is south, right? Now the current is going like this. So what will be the magnitude and direction of the magnetic field? So definitely magnetic field will be created like this as per the right hand thumb rule. So at downside, if you observe, in downside, magnetic field direction will be magnetic field direction will be from north to south. In down, and this distance is at a distance of 1.5 meter below. So distance is 1.5 meter below, right? So how to solve this type of problem? So let's again put the data. So data they have provided you. First of all, they have provided you current as a 90 ampere, right? From east to west direction. What is the magnitude and direction of the magnetic field due to the current 1.5 meter below the line? So the distance R they have provided you 1.5 meter. Now we know that how to solve this type of steps. You know the formula which we can use so for solving this one is equal to B is equal to mu naught by 4 pi into 2I divided by R. So this is 10 to the power 7 into 2 into I is 90 divided by R is 1.5. So this will be, again, why I am writing 10 power minus 7. It should be 10 power minus 7 only, right? Always try to write mu naught. It is having a 10 power minus 7, right? Okay. So it's a 10 to the power minus 7. Again, I have done mistake. So let's rectify it. So when you do this one, so this will be 60. So this is 120 into 10 to the power minus 7 Tesla. So this is the value. So you can also put here B is equal to 1.2 into 10 to the power minus 5 Tesla. So I hope you have understood this one, and the direction will be from north to south downward. So we have provided you the direction. So let's hope that you have understood this question very well. So let's go for next question, that is 4.5. Now if 4.5, when we talk about 4.5, so what is the magnitude of the magnetic force per unit length on a wire carrying a current of 8 ampere making an angle of 30 degree with the direction of the uniform magnetic field of 0.15 Tesla. So first of all, you need to draw the uniform magnetic field. So let us suppose this is the direction of the uniform magnetic field, and I have made this as a equally spaced, right? Now a current, there is a wire which is carrying a current in which direction? So let us suppose this is a wire which is carrying a current I, and I is equal to 8 ampere, right? And this is 30 degree, right? This is 30 degree. Got it? This is 30 degree with the direction of uniform magnetic field of so the magnetic field strength B is equal to 0.15 Tesla, it is, right? So it is given, magnetic field is given. Now what is the force per unit length? Now basically what we know the formula F is equal to BIL sine theta. Now theta also they have provided you 30 degree, right? Now length they have not provided you. So let us suppose F by L. So what is this? Physical quantity. This is your force per unit length. Per unit length. This is what exactly they are asking, and this is equal. This will be equal to BI sine theta, right? So rearrange the above formula. So you will get force per unit length, and this is equal to Bi sine theta. And this entity, they are asking you that what is the force per unit length where will be applied. So B is equal to 0.15 into current. Current is how much? Current is 8 ampere into sine theta means sine 30 degree, right? Sine 30 degree. So this will be 0.15 into 4 because sine 30 is 1 by 2. So this will be 0.6 Newton per meter is the force per unit length. I hope you have understood this question, right? Now let's go for next question. Next question, here we go. Okay. A 3 centimeter wire carrying a current of 10 ampere is placed inside a solenoid perpendicular to its axis. A magnetic field inside the solenoid is given by 0.27 Tesla. What is the magnetic force on the wire? So first of all, you need to draw the solenoid. So let us suppose this is a solenoid. This is a solenoid, right? This is a solenoid. So I am not good in a drawing, but you can understood this. And this is the central axis. And this is its central axis, right? Central axis. And the magnetic field at this point or the central axis, they have provided you as a 0.27 Tesla, right? Right? Now what they are saying, a 3 centimeter wire carrying a current of 10 ampere is placed at inside the solenoid. So there is a wire. Let's draw the wire. So there is a wire inside the solenoid. So let us suppose this is a wire inside the solenoid, right? And this wire itself has a length of how much? 3 centimeter or 0.03 meter, right? Carrying a current I is equal to 10 ampere, right? Is placed inside a solenoid perpendicular to axis. The magnetic field inside the solenoid is given by 0.27 Tesla. What is the magnetic force? F is equal to BIL sine theta. Now the thing is that what is sine theta? The angle between magnetic fields. So let us suppose this is a magnetic field. Direction of magnetic field inside a solenoid. So this is the direction of magnetic field and this is the direction of current. So the angle they have made is 90 degrees. So we can put the values. So here we go, right? 0.2 into current. Current is how much? The current itself is 10 ampere into length is how much? Length is 0.03 meter into sine 90. Now sine 90, just put the value. So this will be how much? 2 into 0.3. So I hope this will be how much? So let me correct. So this is 2.27 because I have not written properly. The value of a magnetic field, that is equal to 0.27, right? So when you put it, it's a 10 into 0.03 into sine 90, that is equal to 1. So you will get 8.1 into 10 to the power minus 2 Newton. And if you want to know the direction, so direction can be found. Direction of force can be found by using Fleming's left hand rule, right? Fleming's left hand rule. So direction can be found out by Fleming's left hand rule. The important is that what is the direction of the magnetic field. Either it may be either it's this side or this side. They have not specified. So whenever they will specify it, so you can get the direction. Only they have asked you the magnitude of a force. If they may ask you the direction of the magnetic field, force. So what to do? You have to use the use your Fleming's left hand rule so that you can get the direction of the force. So I hope you have understood this one. Uh, so let's go for next question. Now, two long and a parallel straight wire A and B carrying a current of 8 ampere and 5 ampere in the same direction are separated by a distance of 4 centimeter. Estimate the force on 10 centimeter section of the wire. So see, the condition they have provided you is that there is a two wire and both are parallel to each other. Both are parallel to each other. So these both are a wire and both are parallel to each other. And this is how much? Estimate the force. So this is separated by 4 centimeter, and we need to find the force between them, right? So let us suppose this is a wire A and this is wire B. So what data they have provided you? They have provided you current at A that is equal to 8 ampere and current at a B that is equal to 5 ampere, right? In the same direction, separated by a distance. So distance they have provided you 4 centimeter. So we can write it as a 0.04 meter, right? And they estimate the force. So length of the wire they have provided you 10 centimeter. So this length, when you talk about this length, so this is your 10 centimeter, right? 10 centimeter. So let's put here 10 centimeter or 0.1 meter, right? So length they have provided you. Now we need to find the force. How to find the force? So the formula used for this type of parallel wire, if you want to find a force, so this will be mu naught Ia Ib into L by 2 pi r, right? R is the separation. R is separation, R or D, whatever you want to find. So since I have considered it here D, so I will take a D. Now mu naught, what is the value of mu naught? So mu naught by 4 pi is equal to 10 to the power minus 7. So mu naught will be equal to 4 pi into 10 to the power minus 7, right? So put the values. So 4 pi into 10 to the power minus 7 into current is 8 into current is 5 into length is 0.1 divided by 2 pi into d is that is 0.04 meter. So 2 pi 2 ja it got cancelled out. So while calculating, so you will get 2 into 10 to the power minus 5 Newton. Hence, our answer for this question is that force is equal to 2 into 10 to the power minus 5 Newton. And right. Uh, so let's write it properly. Yeah. So this is 5. Now, what is the direct? What will happen? So since both are parallel, so both will apply a force on each other. So both wire will attract. Both wire will attract each other, right? Attract each other. I hope you have understood this one. Thank you for watching my video. So next part, which is from 8 to 13 question, so I will discuss in second part. So I hope you have enjoyed our session. So hope try to complete this. Thank you everyone.